In this video, we're going to look at the central limit theorem with proportions. Now, you'll notice I'm not going to spend quite as much time developing the logic of going left, going right, between on the outside because we just did it in section 7.2. So if you haven't watched that video, be sure to watch that video first so that you understand when we're setting up our Excel cells. So the central limit theorem also works for proportions the same way that it does for means, except that our notation is a little bit different and our requirements are a little bit different. So if you'll recall, when we worked with proportions previously, we used P to be X divided by N, where N was the population size. We're also going to add a new notation, which is P hat, and P hat is just our observed value, so it has to do with the sample instead of the population. So this is the population and this is the sample. Now, when we're looking at the central limit theorem for means, our requirement was that the sample size was 30 or greater, or that the population was normally distributed. Now, in this case, the requirement is different. We can't have a normally distributed population because this is going to be proportion. So it's a binomial distribution. So it's not a normal distribution, but if we can show that n times p, n of course being the sample size of the sample, and p is the probability of success, population proportion, if that is greater than or equal to 5 and n times 1 minus p, or I call it q, is greater than or equal to 5, then we can use the central limit theorem. And the mean of our new normal model that we're using is the p, so the mean is just the proportion that we expect, and the standard deviation is found by pq over n, which of course we've talked about this before. Now again, it's p and then 1 minus p, or just pq over n. And then our z-score is now p hat, and p hat is again the sample proportion, minus p, which is our expected mean, divided by the standard deviation, which we're calculating ourselves. As we did in our last video, I'm going to go through the first example step by step with you so that I make sure that you understand all of the parts. And then for the remainder of the examples, we will just work in Excel. So for step 1, obviously first to read the question. So we're looking at a liberal precinct across town. 81% of the voters are Democrats. What's the probability that in a random sample of 100 voters from this precinct, no more than 80 of the voters would be registered Democrats? The first thing you need to find is p hat, p, and n. So n's very easy. N is just obviously the number of voters, so that's 100. And then a lot of people get confused between p hat and p. P hat is what we actually observe. So it says no more than 80 of the voters would be Democrats. So we would be observing 80 out of 100, which is x over n. So 0.8 would be p hat. P is what we expect. It's the mean, if you will, but it's the mean for a proportion, so it's actually a percentage. So in this case, 81% is dealing with the population. So this is the population, and then this is the sample. So it's important to keep those separate. Now, when we draw the curve, again, that's helping us to visualize what's going to go on. So we're expecting 81%. And our question says, what's the probability that no more than 80, well, 80 out of 100 is 80%, so no more than 80%. So 80% is to the left of 81%, and we're saying no more than that. So essentially, this is a less than question, the area to the left. So that's our curve. And the curve just really kind of helps us to determine if we should have a positive or negative z-score, and if it's to the left of the mean, it's negative, and also to determine if we should have greater than 50% or less than 50%. So if the area to the left is 50%, and we've got some space here, obviously it's going to be less than 50%. So that's really a good way to think of it, is just gives you a basic idea. So the z-score, again, I'm going to use the z-score formula that says take p hat minus p hat being my observed value, so 0.8 minus 0.81, and then divided by the standard deviation, which is the 0.81, that's p, and then remember q, or 1 minus p, that's where I got the 0.19, and then divided by 100, and that's the square root of that whole thing. And so my z-score is negative 0.2549. Once you find the z-score, you're going to calculate the probability. And our probability here is, again, we drew our curve, so we knew we were going to the left. So notice I've used just norm S dist because that goes to the left. And I've included my z-score value that I found previously. And that gives me the 0.3994, which gives me a conclusion that the probability that no more than 80 voters in a randomly selected sample of 100 voters being registered Democrats is approximately 39.94%. Let's take a look at the same question now, doing everything we can in Excel. So this one's going to be a little bit more involved than the means question we just looked at, because we have to do a little bit more calculation. So you can make your input values as simple or complex as you'd like. It really kind of depends on your strategy. For the mean, remember that's the p-value, so that's just the 0.81 that we're given, and make sure you do enter it as a decimal. The sample size in this case is 100 because there are 100 voters from the precinct. The observed value, I can either calculate that myself, or I could set up cells to enter X and N, and you can certainly do it that way. Or I could just put 80 divided by 100 and find 0.8. So again, that's something else you could do. I could insert this here and shift the cells down, and then enter observed X, and then this would be my observed proportion instead of observed value. And it's really up to you, but I could say my observed was 80, and so 80 out of 100 would be then equals X divided by N. So again, get as complicated or as simple as you'd like. For standard deviation, remember that the formula says the standard deviation is the square root of p times 1 minus p over n. So I'm going to do square root, parenthesis, and then p, and then times, and again, some people like to create a separate cell for 1 minus p, and you can, or you can put a parenthesis and 1 minus p, and close the parenthesis, and then divided by n. And that's my standard deviation. That's going to make my z-score easier to calculate because my z-score is my p hat minus p. Notice I've put the numerator in parentheses and then divided by the standard deviation. So that gives me the same z-score that we had found by hand. And then, of course, if we're finding less than, which is what we just did in this question, it would just be norm S dist, and then that z-score, and then comma 1. And if you'll recall, that was the probability that we found previously. Looking at our next question, we're now looking for more than, or excuse me, at least, which would be the same as more than. And so again, if it helps you, you can write more than, and then underneath you can write at least, so that you remember those are the same things. So again, what we're looking at here is a mean of 79%, and that is what we're expecting from Republicans in this other district. We still have 100 voters. The question says 68, at least 68. So 68 would be 68 or more. And so again, I'm going to really just enter those values. My z-score would be 0.68 minus 0.79 divided by this standard deviation, which has to be calculated. And that gives me a z-score of negative 0.7. And if I'm looking at the area to the right, at least would be 68 or more voters. So more than is going to be 1 minus norm S dist, and then the z-score, comma 1. So the z-score, comma 1 is going to be everything to the left, and then I want the area to the right. So if we're expecting 79%, and we get 68%, we're saying at least 68%. So again, if you have trouble visualizing it, draw the little picture. We have the normal model. It doesn't have to be a good normal model, obviously. We're expecting 79%, 68% somewhere way down here. And we're saying, what's the probability of 68% or more? So it would make perfect sense that that value is going to be almost 100%. Let's look at another example now in differing by less than. And if you'll recall, when we thought about that picture before, I keep doing that, I'm sorry. If I thought about my really ugly picture before, what I'm saying is I've got some value that I'm expecting, in this case 8.3%, and I'm saying what's the probability that the sample differs from the proportion by less than 1%. So I'm going essentially 1% in each direction, 7.3% to 9.3%. I want to find this area in the middle, and one way to do that is to find the area to the left of the lower value and double it to account for the area to the right of the upper value and take that away from 1. So again, my mean is 8.3%, so that's 0.083. Make sure you do that conversion correctly. The sample size is 74. And my observed value, the easiest thing to do is to find the lower one. So my observed is 0.073, 7.3%. Oops, 0.073. So I'm going to get rid of that one. So again, the standard deviation is automatically going to be found for me. My z-score is automatically going to be found. My observed minus my expected divided by the standard deviation. And then differs by less, I'm going to take 1 minus 2 times, and then I'm going to go norm S dist, and then my z-score to the left. So I'm finding the area to the left of my z-score. I'm doubling it to give me both pink regions, and then I'm taking it away from 1. Now, keep in mind, essentially what I've done is I've doubled this value and taken it away from 1. So that makes perfect sense. For our last question, again, if you want to visualize what's happening, we're saying 8.3 is still in the middle. And now we're looking at what's the probability that the sample differs from the population by more than 2%. So we're saying if this is 6.3% and this is 10.3%, we want to only find the area in the tails. So again, the two tails are going to be the same. And so all I need to do is find the area in one tail and double it. So the mean is still 8.3. The sample size here now is 91. I don't need an observed X value. I just need the P hat value. And again, we're going to use that lower value, so 0.063, the 6.3%. And again, you can always calculate that. You can say the mean minus 2%. Sorry, 0.02, since that's 2. And that would calculate it for you as well. But again, that's going to give me my z-score. And then differs by more, I'm just going to take 2 times norm S dist, because that's going to find the area to the left, and I'm going to basically take 2 of those. Whoops, I forgot to put comma 1. Comma 1. And that gives me differs by more than 2%. Hopefully you're starting to get the hang of this. What we're doing next is having just a little introduction to confidence intervals before we get into sort of the nuts and bolts of all of the different ways to do a confidence interval.